We want to find all of the zeros or roots of the given degree 3 polynomial function. To do this, we want to start by finding the real rational zeros, and there are two ways to do this. We could list the possible rational zeros using the rational zeros theorem, which says the rational zeros would be the ratio of the factors of the constant term, in this case 2, over the factors of the leading coefficient, which in this case would be positive 1. Which gives us a fairly small list of rational zeros to try. The factors of 2 are plus or minus 1 and plus or minus 2, and of course the factors of 1 are just plus or minus 1. So the ratio of these would just give us possible rational zeros of plus or minus 1 and plus or minus 2. But instead of doing trial and error here, what we're going to do is graph the function and look for our x-intercepts. Remember, the x-intercepts would represent all of the real zeros of our function. So if we graph this function, it would look like this. Notice how there are 3 x-intercepts, therefore we do have 3 real zeros, but we're actually only going to use the rational zeros, because if it's irrational, we're going to find the exact values. Notice the 2 zeros on the right side, this 0 here and this 0 here. It's hard to tell exactly what x value that would be, but the 0 on the left we can tell is x equals negative 2. So we're going to use this 0 to help us factor the given function and then find the remaining zeros. So again, we know from our graph, one of our zeros is x equals negative 2, and because x equals negative 2 is a 0, we know that x plus 2 would be a factor of our function, which means we can write this as f of x equals a factor of x plus 2. Notice how this is a degree 1 factor, and therefore the other factor would be a degree 2 factor or a quadratic factor. So to find this factor, we can divide the given function by x plus 2, or we can perform synthetic division using x equals negative 2. Let's use synthetic division. Again, because we know negative 2 is a 0, the remainder of this should be 0. So we have negative 2 here, and then we'll list the coefficients, which are 1, negative 4, negative 11, and positive 2. To start, we bring the 1 down, and now we start multiplying by negative 2. So 1 times negative 2 is negative 2. Place this here. We add vertically, so this would be negative 6 times negative 2 is positive 12. Add, this would be positive 1. Multiply, that'd be negative 2. Our remainder is 0. Which again is good news. This verifies algebraically we have a 0 of negative 2. This also gives us the coefficients here of our degree 2 factor. The other factor of our function would be x squared, or 1x squared, minus 6x plus positive 1. Now again, we already found the 0 from this factor, the 0 of negative 2. Now we want to find the zeros of the quadratic factor. And since there are no factors of 1 that add to negative 6, this is not factorable. So to find the zeros of this factor, we'll have to use the quadratic formula. Let's go ahead and do that on the next slide. So again, now we want to find when x squared minus 6x plus 1 is equal to 0, this will give us our 2 remaining zeros. So here's the quadratic formula if we need to see it. We should recognize that a is equal to 1, b is equal to negative 6, and c is equal to positive 1. So we have x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times a times c all over 2 times a. Now we'll simplify. This will be positive 6 plus or minus the square root of, this is going to be 36 minus 4, that's 32, all over positive 2. Now we need to be careful here. We cannot simplify the 6 and the 2 here. We first want to simplify the square root of 32. Well, the square root of 32 is the same as the square root of 16 times 2. The square root of 16 is 4. So now we have 6 plus or minus 4 square root 2 all over 2. Again, to avoid a simplifying mistake by simplifying the 6 and the 2, let's go ahead and write this as two separate fractions. We'd have 6 over 2 plus or minus 4 square root 2 over 2. Well, 6 over 2 is 3, plus or minus 4 over 2 is 2, so we have 3 plus or minus 2 square root 2. These are the two remaining zeros of our cubic function. So we go back to the previous slide. We now know our zeros are x equals negative 2. If we want to separate them, we can write x equals 3 plus 2 square root 2 and x equals 3 minus 2 square root 2. Okay, I hope you found this helpful.